Hello and welcome to I'm gonna do this week's Perl Weekly Challenge. Oop. If I can find the correct website. So let's go to the challenge of the week. I've been doing these for a few weeks. I haven't done all of them. And a big shout out to Mohammed Anwar for thanking me for introducing him to APL. That is part of the point of me doing this. I'm hoping to introduce more people to APL. Right, let's have a look. So first thing I do is create a link between my active workspace and the folder. First thing is to make a namespace for my week 60 solutions. And enter that namespace. Right, we're going to take a number and we want to return the Excel column name where they're basically a base 26 conversion and then indexed into the alphabet. So let's do that. So the 28th one will be, you know, after the fact I can go back and tell you what it does. But yes, it's 26 base power -1 of omega converts our decimal number into base 26. This year's APL problem solving competition has a really similar problem, but just in reverse. So I'll leave that as an exercise for the viewer. I won't give spoilers here, although I already have, I suppose. Next, find numbers. Write a script that accepts a list of positive numbers. So the at there in Raku or Perl is going to indicate an array, but everything is array in APL, so we're just going to be happy with some list of numbers. Okay, we accept a list of positive numbers and two positive numbers. Print all the possible numbers made by concatenating. So this is basically a matter of defining things, I think. This is digits, concatenating digits. So we could do an outer product catenation selfie of omega. So now we've got all the combinations. We'll make sure boxing's on and you can see the structure a bit better. So there's a nested matrix of all of those numbers. And then we can just filter out the ones. But does this mean if you had a 3 on the left, you'd actually want, you know, these the numbers catenated together again? I guess it wouldn't be like that. It would be more like you wouldn't want repeated numbers, I suppose, right? So all the leading diagonal here is invalid because presumably it's just unique. Oh no, it's not unique combinations. It's do what you like. Okay, so that would be right, and you'd want. Can you do that with power? Power 2? Yeah, buddy. Haha. So if we just make sure that we do an outer product, so the outer product, number of times using power, is to repeat the function n times, and n is going to be -1 plus the first argument in alpha. Okay, so if we want concatenation of digits whose length is 2, then we'll do the outer product just once. Yeah, and if the length is 1, then you just do it 0 times. So no up. Okay, I'm happy with that. Then we're just going to find the value. Oh, okay, so we need to bring these numbers together. No, 10 base 2, 3. Oh, it's just 10 base each, 10 job base each. Now they're all numbers. We can find elements where the second of alpha, which is our y value is less than, strictly less than. So it's probably worth raveling the whole thing at this point. So we probably want to assign that value. This is getting a bit larger now, so I'm going to turn it into an actual function called find numbers. Alpha is 2 numbers to, if we're talking about length, we're assuming integers. We can have a float and an int. Omega is an array of numbers, and C is the ravel of the outer product concatenation of omega. Oh, selfie. Alright, all elements of omega concatenated with themselves. The numbers are the base 10 representations. Let's see, the length is neg1 plus the first of neg1 plus x, which I guess we can define up here and say it's the and then our max value is y. So that's just y. Now where are we up to? So yeah. So we've got some numbers, and then we want the actual numbers. Numbers filtered by 2 things. We need to make a Boolean mask with 2 features. So let's take our example inputs. Control enter, go into here. Here's our numbers. We want to know where 10 to the power of L greater than or equal to n. And we want to know where n is less than y. Or is it exclusive or? It's exclusive or. 11. We're missing 10. That was greater than or equal to, not correct. There we go. So it's n selected by values where its length is less than x. Sorry, length is exactly x. Oh, if its length is exactly x. Oh, presumably n less than y filters out numbers where the length is greater. So I think we're happy with this. And then I like to try and comment things. A float x and integer y. Oh, it's the other way around because x is the length. And integer length x. Any real number y. That's not the number of digits. That's the base 10 logarithm. What is L? It's related to the length, which is why I named it L. But I don't actually have a succinct description for it right now. It's the power of 10 with x digits. I think that's as good as I'm going to get, right? Because if it was 2, then it's 3-digit numbers, right? And if x is 2 and we want a power of 10 with 2 digits, that's just 10. That's my logic. And we can describe what the function does here as well. So the function returns all numbers made by numbers with digits made by concatenating elements in omega, whose value is, whose length, all numbers which have exactly x digits and a value less than y. Blah 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 blah. All possible concatenations of omega. It's literally the definition. Raveled in base 10. Filter out Oh, and then this is just the definition of the problem. Because I just put the arrow, maybe that's good enough. And then we make it all pretty, lining up the comments. Yep, and those are my solutions to this week's Perl Weekly Challenge. Just to recap, if we look at the Excel column solution, we're just converting our number into base. Like 30 should be AD, is it? Nice. So yeah, just converting your numbers into base 26 and indexing into the alphabet. And then find numbers ended up being a bit more involved, although we're 50% comments, 50% code here. This has been a good demo of the base. So binary decode, or well, it's mixed radix decode, but we've only been using it for conversion to base 26 or conversion of separate numbers into a single base 10 number. 4 times 10 to the 0, 3 times 10, 2 times 10 squared, 1 times 10 cubed. Anyway, yeah, so this has been a week of base conversion. Super fun. Hopefully this gives a little bit more of an insight into the fumbling mess of a way that I sometimes solve problems in APL, and yeah, hope it was interesting. Thanks for watching. See you later. Yeah, if I'm gonna have a go in the first one seems like a good converter. I don't know how I'd approach base conversion in Perl. Just Google it or something. Mastering Raku. No. What is that? Is Raku a type of my Raku kiln? I don't know what the name comes from. Aha, someone's done it in Raku already. See, I can just steal. Oh, is it inbuilt as well?